So let's talk about your test. There's going to be around 8 or so multiple choicey questions. I guarantee probably one question for multiple choice will be units. So newtons is the unit. What do we measure in newtons? Okay, but also a newton is technically a kilogram meter per second squared, since F equals what? Well, if it's MA, it must be kilogram meters per second squared. There'll be a question that asks if you know the difference between weight and mass. Which one is the gravitational force acting on you, your weight or your mass? Which one is mg, your weight or your mass? Which one's measured in newtons? Weight, okay? And that's me both being fussy, but I think it's actually kind of important. I'll be showing you a video later today that looks at some of the effects of that. Then there's going to be probably some actual elevator questions on your test, as well as conceptual elevator questions. What do I mean by a conceptual elevator question? It might be something like, if you know the elevator is accelerating down, will the scale read more than the normal force, more than mg, equal to mg, or less than mg? If the elevator is accelerating down and you're standing on a scale, will the scale read more than mg, or less than mg? Okay, so I can do some questions like that. There's probably going to be a conceptual question involving Newton's laws. You don't need to memorize which one is which. There will be no question that says something like, which of these is an example of Newton's third? But I will certainly feel fair game to say something like, if you know an object is traveling north but slowing down, which way is the net force? If you're traveling north but you're slowing down, what direction is the force? If you're traveling north but slowing down, you're accelerating south, so the net force must be south. Okay, something like that. Or I might use left and right or up and down, but probably north and south, because that gives me 4 different options and it's multiple choice. Okay. What about the written section? One of the first questions on the written section is going to be a net force. A what force? In fact, the first question. Either you'll have F equals ma, or maybe I'll give you 2 of those 3. I might say, here's the force, here's the acceleration, find the mass. I might say, here's the acceleration, here's the mass, find the force. That's the easiest one. I might say, here's the force, here's the mass, find the acceleration. Then what? Well, let's mark the quiz. There's definitely going to be an Atwood machine. It'll be near the end of your test. What does A want me to find? The acceleration. Although, Casey, I noticed something. Casey, how big is M1? Read it to me. How big is M2? Are they close? If M1 was 21.3 and M2 was 21.3, if both masses were the same, what would the acceleration be exactly as a number? 0. The fact that they're close, I haven't done the math yet, but I bet you got a small acceleration. I'm betting it was less than 1. Okay, I can make, so there's kind of, when you get a feel for these, you can make some predictions. You kind of can check if you made a typo on your calculator. I'm pretty sure it's going to be a small acceleration. Oh, and the tension, what was M1, Casey? What was M2? I know most of you think in pounds still. This is roughly a total of about 100 pounds. There's a fair bit of mass. Willing to bet you got a tension in the hundreds, like 100, 200, 300 range. You didn't get a tension of like 35 newtons. Just predictions I'm going to make. Now let's do the question. How will I start this? This is a good job for it. All right, so I'm going to have M1G tension, M2G tension. Casey, which mass was bigger? Which force is winning? Sorry, which mass is bigger? M1. Which force is winning? Yeah, M1G. So it's accelerating this way. I often, for Atwood machines, will put a little A arrow so I don't get it mixed up and accidentally forget. Pause the video for a second. And Casey, you're right. Now I can write my equation. Who's winning? M1G. And then I have minus tension, and then I have plus tension, because the other tension would curl around and end up pointing in the winning direction. And then I have minus M1G. That equals M all A. Mr. Dewick, what, Declan? Do I have to write the tensions if I know they cancel? I won't take marks off if you don't. But then you're going to be missing out on the opportunity to stretch and lose tension. But I'm not that fussy. What's part A want me to find? How am I going to get the A by itself? divide by m, Declan's theorem. So next line I would say A equals m1g minus, I wrote an m1 twice for some dumb reason. You were probably noticing that. I did catch it. m1g minus m2g all over m1 plus m2. Now I'll plug in the numbers. 21.3 times 9.8 minus 19.6 times 9.8 all over 21.3 plus 19.6. So you need to be comfortable with being able to type stuff like this into your calculator. If you don't have the fancy smancy fraction button, it definitely brackets around the top. 21.3 times 9.8 minus 19.6 times 9.8, close bracket, divided by, and brackets around the bottom. 21.3 plus 19.6. Did you all get 0.407 meters per second squared? And that was pretty much my prediction. I said this is barely going to accelerate because the masses are almost identical. Casey, how many marks was part A worth? Yep. Yep. How many marks was it worth? How many lines did I write? Would it be clever? One line. So if you got it right, 4 out of 4. Even if you took shortcuts. I tend not to take shortcuts on a test or a quiz, so I would also say I would give you 1 mark if I saw the winner minus loser equation, 1 mark for dividing by m using Declan's theorem, 1 mark for the numbers, 1 mark for the answer. So do you ever want to leave these blank? No. Lots of part marks. Lots of part marks. Also, let's suppose you can't remember how to do part A, but you know that you're going to use your answer from A to do B. I have no problem if you write a note for part B. Mr. Duick, I can't remember how to do part A. I'll make up an answer. I'll pretend the acceleration is 1.5, and I'll show you I could do part B. I'll give you full marks for part B. I'll get up my calculator. I'll crunch your numbers. Oh, you did it completely right with the wrong starting value, but I'm not going to penalize for that. Meanwhile, this wants me to find the tension in the chord. I can do it one of 2 ways. I can either go tension minus m2g equals m2a. I can use the right-hand mass, which I might do because tension is winning, and it's easier to get tension by itself. I would just plus the m2g over, so it's going to be m2a plus m2g. Or I could go m1, wrong color, Mr. Duick, m1g minus tension equals m1a, swappy dance, and I'll get m1g minus m1a equals tension. And I think I didn't do this one in my head. I'm going from memory. It works out to almost exactly 200 newtons, doesn't it? It's like 200.01 or something like that. So whichever way you did it, I would give you 3 marks, and I would give you 1 mark, 1 mark, answer, 1 mark, or 1 mark, 1 mark, answer, 1 mark. Yes. Next time go during lunch. Quick like a money, but next time go during lunch. Pardon me? They're all locked during lunch? Really? Okay, I'm going to do something about that. That's not acceptable. No, I'm serious. Got to treat you like adults. I'll find out what the deal is. We're still stuck with some of the guidelines from the province because it's a bureaucracy around COVID. I'm hopeful come fall, because honestly, we're so close to the end of the year, I can also see them just rolling their eyes and saying, no, we're not going to change it for the final month and a half, because that means new documents, new safety training, another staff PowerPoint, another staff assembly, another student assembly. I can see them just saying, go with it, which isn't always the best reasoning, but I get it. There's going to be one like number 2 on your test. What do I mean by like number 2? Sarah Ashley, where there's an extra vertical force, either pushing up or pushing down. In fact, I'll even be blatant. I've got 4 versions of this test. I'll bet you in 2 of them, someone's lifting up, like this one, and I bet you in 2 of them, someone's pushing down, like not this one. What's the key here? Normal forces, not mg. However, Sarah Ashley, what does part A want me to find? Sorry, what does number 2 want me to find? There's no part A. What does it want me to? Any suggestions on how I might want to start? Yeah. And hopefully you're at the point now where your brain just looks and says, wants you to find A. They gave me some forces. I don't see a T or a VI or a V, where you don't even have to do a rejection. You go straight to free body diagram. Let's try that. What are the forces acting on this, Sarah Ashley? Get the obvious one. Good. Change colors, Mr. Duke. What else? Normal force. Is the normal force bigger, smaller, or the same size as mg here? Yeah, it's smaller because someone's lifting up with 19, so the normal force only has to cancel out part of gravity. And then we've given the mystery force coming from off the page. We've called that F applied. And I guess there's friction. Okay. Who's winning? Who's losing? Equals? Yep. Well done. This is F net equals MA in disguise. This is the generic one size that I can fit into any equation that I gave you, because I couldn't make up every single equation. What are we trying to find? Ooh, Declan's theorem. Divide by M. I also stuck in mu times the normal force for friction at the same time as I divided by M. I don't know the normal force. And this is not one of those easy ones where I can say, oh, but look, there's another force the same size as the normal force, because there's an extra vertical force. You'll see it. I'm going to have to do some thinking over here in the margin. Sarah Ashley, are we sinking to the ground like quicksand? Are we flying here like Superman? So that really means everything down has to equal everything. So what's everything down? mg has to equal, what's everything up? The normal force and plus 19. Now I can figure out the normal force. How would I get the Fn by itself? How would I move that plus 19 over? Yep. The normal force is mg minus 19. I usually am so lazy that I just drop this expression in, but I know some of you are a little more comfortable with numbers. If you actually crunched that and you said, okay, 3.6 times 9.8 minus 19, is it 16.28? If you crunched that, I'm fine with that. I would use my answer button if there was a long decimal. I would not round off because this is not the answer, and I don't want to use a rounded off answer to find an answer. I'm going to do this algebraically, though, so that I'm going to go A equals F applied minus mu, and then in brackets mg minus 19 all over m. That's still F applied minus mu times the normal force. But if you put the 16.28 right there, not a problem. I always kind of like to see if I can just type once on my calculator and go to an answer and be done. So it's going to be 12 minus 0.48, 3.6 times 9.8 minus 19, all divided by 3.6. I have a feeling we're not going to get a very big acceleration here, because pulling with 12 newtons is not a very big force. I have a feeling it's going to be like, not large. Bracket minus 0.48, open up another bracket, 3.6 times 9.8 minus 19, close off the small mini bracket, close off the top, divided by 3.6. Did you all get 1.16? Yep. If you got that, 3 out of 3 meters per second squared. Otherwise, I would probably go half mark for that, half mark for that, half mark if I saw that, half mark for finding either version of the normal force, whether it's the equation or the number. Half mark if I saw that you plugged the normal force, not mg, in. 1, 2, 3, 4, 5, and a half mark for the answer. Something like that. Good stretch, Sarah? Good. Yep. Quick like a bunny. Number 3, here's an example of a multiple choice question. Consider the 12 kilogram mass below. What would be the acceleration of... Okay. You know what? I'm going to do kind of a sloppy free body diagram. I got that. I think it's just going to be who's winning, 60, minus who's losing, 36. Those are in newtons. They gave me the force, equals MA, and then I would apply Declan's theorem. And I think I do it in my head, because M is 2. 60 take away 36 is 24 divided by 2, divided by 12, not 2, divided by 12. It's 2. Yeah, it's B. Is it? Yeah. Number 4A wants me to draw a free body diagram. Somewhere on your test, I will ask you to draw a free body diagram, but you definitely wouldn't want to be looking at your phone during that section. Right? Right. Right? Right. Put the phone away, please. Thank you. I forgot to tell you, normally what I say when I hand the quiz out, I say, draw the free body diagram in the white space here. If you labeled the picture, I'll give you credit, but on the test, I will ask you to draw the free body diagram in the white space. It makes it easier for me to spot arrow lengths and things like that. So, Riley, there's my free body diagram. What are the forces acting on this mass?
Yeah.
Which way?
Yeah.
Okay. What else?
Normal force.
Bigger, smaller, or the same size as gravity?
Same size.
Okay. When would it be bigger? If there was an extra force pushing down, which would give me another force right there. When would it be smaller? If there was an extra force lifting up, which would give me a smaller normal force right there. I think that's all the possibilities I can throw at you vertically. So, same size, I agree. What else?
Force applied.
Yep. Bigger, smaller, or the same size as F applied? What if I told you that this was moving at a constant speed? How would friction compare to F applied? What if I told you it was at rest? How would friction compare to F applied? If it's at rest, what's its acceleration? Which means forces must be. So, if it was at rest, how would friction compare to F applied? Same size, just like constant speed. This is why I keep yelling at all of you. Newton's laws tell us nothing about how it's moving. They tell us how it's accelerating. And if it's at rest or moving at a constant speed, both of those, A is 0. Oh, what if I told you it was moving to the right but slowing down? How would friction compare to F applied? I think that's every single possibility I can come up with. Can't think of another one. So I agree with you. Riley, how many marks is this worth? Part A?
62.
How many lines did I draw?
4.
Half mark per line. Probably what I'd go with here. Okay. So what would I be looking for this specific free body diagram? Your normal and your mg look about the same if you eyeball it, and F applied is bigger than friction. Find the acceleration. Well, now Riley's made it easy because I look at my free body diagram. It's pretty obvious. F applied is winning. Friction is losing. And that equals MA. What else could I ask? I guess instead of asking for the acceleration, I could give you the acceleration and say find mu, which is hidden in here. I've done a few of those. It's an advanced question, so I don't know. I may ask that on the test. I might not. I've done them on the quiz with you. For now, I think we can use Declan's theorem. That's going to give us A equals F applied minus mu times the normal force all over M. Riley, I don't know the normal force. So I would live with it if you just did that because this is an easier one. I would not do that if I noticed there was an extra vertical force. I would be much more meticulous. By the way, this is a weird question. I don't know why this happens, but it seems to happen fairly often. Sadie, what's the applied force as a magnitude? What did they tell me? How big is it? Loud and proud. You're right. For some reason, the number of times I've seen kids write 255 down here, I don't know what it is about this weird number, but wow, I've seen a lot of kids somehow just instead of 225, 255. Be really meticulous, Paul, when you're copying and writing stuff, because that to me is throwing away silly marks, copying a number down wrong, and you're like, ah. What's F applied? 225 minus what's mu? 0.15. M, 100 times 9. You know what? We're going to get a really small acceleration. We might even get a negative acceleration because 100 kilograms, Riley, that's a heavy mass. 225 newtons, not that big a force. Now, the coefficient of friction is fairly small, so we're on fairly slippery ground. It might be accelerating. How would I tell if I guessed the wrong winner? When I solved for A, it would be what? Negative. Don't panic. I just go back, change the lengths of some of my arrows, and redo my free body diagram and different winner. It's a pretty quick fix. I'm doing some quick math in my head. I think we're okay. 225, Mr. Duke. Minus 0.15 times 100 times 9.
Times 10.
0.8. Thank you. Divided by 100. Oh, do you get 0.78? Yeah, I figured it was going to be accelerating, but barely. If you got that 2 out of 2, otherwise half mark for the equation, half mark for dividing by m, half mark for the numbers, and a half mark for the answer. Now we're going to kick it up a notch. There is going to be a question like number 5 where I have a hanging mass and friction. This is a job for a free body diagram. M1G. Normal force 1. Tension. Don't forget friction. I'm going to call it friction force number 1 to go with mass number 1. Here, M2G. Tension. Who's winning? Well, if anything is winning, it's M2G. Either everything is sliding off the cliff, or maybe friction is so big that it's at rest. I just know there's no way that a box will suddenly on its own start crawling left and lifting something up. The universe doesn't work that way. So I'm going to assume that this is winning. I'm going to assume M2G is the winner. And now I'm going to write an equation along the rope for the forces along the rope. So it's going to be minus tension, plus tension, minus friction force number 1. A common mistake I see, can you all look up? I see a lot of kids want to include minus M1G. Is M1G along the rope? It's not going to show up. Equals M all A. Stretch. You want me to find the acceleration? Divide by A. So it's going to be A equals M2G minus mu times normal force number 1 all over M1 plus M2. I don't know the normal force. Oh, but look. That's going to be M. That's where M1G shows up inside of friction, but not as a separate force. Now what? Plug in the numbers. A equals 4.2 times 9.8 minus 0.19 times 6.3 times 9.8 all over 4.2 plus 6.3 or 6.3 plus 4.2. Bracket 4.2 times 4.6?
Yeah.
Oh, I read that wrong. Duh. I went on my rant about being careful in what you're reading, and then I did that. That was silly. 4.6 times 9.8. I also got a missing bracket right there. Minus 0.19 times 6.3 times 9.8. Close off the top. Divided by, open up the bottom, 4.6 plus 6.3. Did you all get, oh, wait a minute, Mr. Duick. What did I type wrong here? I put a minus sign instead of a times right there. So it alerted me that I got a negative. Something's wonky. I said, let's check my typing first of all. Did you get 3.06?
Yeah.
That's better. Can you wait till I'm done marking the quiz, kiddo? Thank you. Almost done. 3.06 meters per second squared. 1 mark, 1 mark, 1 mark. Is that right?
Yeah, I just rounded wrong.
Oh, you didn't go 3.05, did you?
Like 3.10.
I would accept 3.1 to 2 sig figs, but I would recommend go to 3.
Yeah.
Easy peasy. So I'd give you full credit, but I'd also give you a bit of a stink eye next time I saw you. Find the tension in the rope. Which would be a much smarter mass to use? Yeah, I'm going to use this one. It's less cluttered. Less cluttered. So I'm going to go M2G minus tension equals M2A. I realize that means I've still got to do a swappy dance, but it's so much less cluttered. Tension is going to be M2G minus M2A. It's going to be 4.6 times 9.8 minus 4.6 times, I'm going to write 3.06, but you know I'm using my answer button. Did you all get almost exactly 31? 31.00 newtons. If you got that, 2 out of 2. Otherwise, a half mark for each line. Half mark for that. Half mark for getting the t by itself. Half mark for that. Half mark for the answer. And then there's going to be a missing mass question. Probably a missing mass question involving an Atwood machine. But here's one that's a missing mass question. Not an Atwood machine, but still 2 masses. What's my strategy? Well, it says find tension first. I'm going to use mass 1. M1G, normal force, tension. Is there friction? No. Who's winning? Tension. Who's losing? It's a trick question. No one. So it's going to just be tension equals M1A. No loser. This was kind of nice. Tension is going to be M1, 4.2, times 3.2. Tension is going to be 13.4. 13.44. I'll store that on my calculator so I use it next. Cool. Paul, what does B want me to find? I'm going to write an equation for mass 2. What are the forces acting on it? Get the obvious one. What else? Good. Which way is M2 accelerating? Which force is winning then? M2 is not a force. Which force is winning? M2. Okay. So who's winning? Say it again. Who's losing? And we're going to stop there. That equals M2A. We're just writing an equation for our mystery mass. I'm trying to find M2. Paul, how many M2s do I have here? 2. How many would I prefer? Get them to the same side. I think I'll swap you dance. Yep. You go, nerd. You go. Excellent. So you said now we GCF. It's always nice when Math 9 comes in useful. And then how would I get the M2 by itself? How will I move the bracket over? Well, if the bracket's multiplying, I'll divide. I'll get M2 is equal to tension divided by G minus A. It's going to be tension, which was 13.44, I think. Was it 13.44, Mr. Dewitt? Yeah, it was. Divided by 9.8 minus 3.2. Answer button divided by bracket 9.8, take away 3.2. And I get 2.04 kilograms. If you need to lawyer with me, now is the time. Otherwise, if you would be so kind as to give yourself a clear score out of 27 and pass the quizzes inwards.